Okay, we're back to just do two problems to finish up in this set. I didn't want to make the last video too long. So 20 and 22, just to get a feel about when this index is not something you're most familiar with, 2. The author starts out with square root frequently, but then we're starting to jump this up to the third root and the fourth root. So the technique takes over and not simply prior knowledge from a previous class. So we'd like to break the 54 up. Now, it would be ideal if we have a cube that goes into it. Memorizing your cubes will be helpful here. What you're going to see me do is use 27 here, because 27 times 2 is 54, and 27 is a cube. You can break this up a bunch of different ways. You can break this up with 9 times 6, and then break these zeros up and make a factor tree. You can make a factor tree for the 16, same thing. I'm going to put this as 8 times 2, because 8 is a cube. It, of course, is 2 to the 4th, but I need a third power. So here we go. I'm going to break this up as the third root of 27 times 2 plus the third root of 8 times 2. I'm doing so because I'm dealing with cubes, and that's a perfect cube, 3 to the third. And that's a perfect cube, 2 to the third. So 3 to the third over 3 times 2 to the first over 3 is the first rational radical. Plus, this is 2 to the third is 8 over 3, my denominator, times 2 to the 1 over 3. And you can see how it's tying into the lesson with the common factor. So the integer ones would be 3 times the third root of 2, I'm putting it back in radical form, as there's nothing more I can do with it, plus 2, the third root of 2. You can put this back in the radical form here. You can actually leave it 2 to the 1/3 and put it back radical form last. It doesn't matter at this point. This would then be a common factor. Both of them are multiplied by the cube root, so it's 3 plus 2 times the third root of 2. Which turns out to be a total of 5 times the cube root of 2. All right, one more, 22. I really encourage you to please try the odd problems. You really can't get good at this. Just need practice. And I know there's frustration, and I know it's not easy. Trust me, I get that. Being on your own and being forced to do this without being able to ask direct questions has to be a little bit tough. Okay, now, again, I'm at a little bit of advantage where I know a little bit of fourth powers too. So let me go, pretend we don't. And I'm going to bring this down all the way into its prime factorization. This is 8 times 4, the fourth root, which is 2 to the third times 2 to the second. Now, of course, if you're ahead of this, just a shortcut on this, this is 16 times 2, and 16 is 2 times 2 times 2 times 2. It's a fourth power. This is 16 times 3. And 16, of course, is a fourth power. That's generally what's going to end up happening if you happen to know and start memorizing some of these things. It makes your work a lot easier. You can still get there, though. Plus the fourth root. And I'm going to make this at 8 times 6. And now we'll break this down into prime factorization. That's 2 to the third times 2 to the second, the fourth root, 2 to the third, and 2 by 3 is 6. Now, when we multiply, we add the exponents, so it's the fourth root of 2 to the fifth, plus the fourth root of 2 to the fourth times 3. Now, we can see in the second one, that's going to have a 4 over 4. That'll be an integer. That'll be great. However, 4 doesn't go into 5 evenly, so we break this up as 4 plus 1, like we did in the previous section. So, over here we have the fourth root of 2 to the 4th times 2 to the 1st, which is 2 to the 5th, plus the 4th root, 2 to the 4th, 3 to the 1st. Exponent form, 2 to the 4 over 4, 2 to the 1 over 4, plus 2 to the 4 over 4, 3 to the 1 over 4. You cannot add until you multiply. Multiplication comes before addition, subtraction. So this addition will actually never occur. What we'll do is we'll simplify. We have a common here. This is just 2. And I'll put this back under the index, the 4th root of 2. And this becomes 2 whole, and the 4th root of 3. Now, as they both have a common factor of 2, we would end up having here 2 plus, we take the 2 out, times 2. Not much more you can do here because you're adding them, you're not multiplying them. All right, thank you very much. I'll stop here.